In episode 75 of Mobycast, we continue with part 3 of our series on encryption. In particular, we discuss end-to-end encryption in practice. Welcome to Mobycast, a weekly conversation about cloud-native development, AWS, and building distributed systems. Let's jump right in.
Welcome, Chris and Rich. It's another episode of Mobycast.
Hey
guys, good to be back.
Good to have you back. So we are recording on the day before the weekend. That would be a Friday. I've never asked this question ever before. Rich, do you have any plans this weekend? Anything fun?
I rarely have plans. I feel like I work all the time these days, but if the weather holds out nice, I'll definitely try to get outside and at least get some sun.
It's just like where you're working from. You'll send me Instagrams of you working from your boat this weekend.
Yeah, I wish it was that much.
Instead of the office, you'd be working from the boat.
Yeah, because great Wi-Fi from that boat.
Yeah, and by the way, your bathtub does not qualify as a boat.
Well, then it's out. You're not going to get it. Plus, that'd be an odd Instagram photo to send you.
Yes, I don't want that one. Chris, how about you? Any plans for the weekend?
Yeah, lately, this is July, August, so my weekend plans are usually long bike rides. So that's when I get out and put the hammer down. So usually where I ride with a good friend as well, that we like to make each other suffer quite a bit. So that's on tap this weekend, and just the usual litany of chores and yard work and all that other kind of fun stuff.
Cool. If you don't get a Strava PR or KOM, don't bother coming in on Monday.
KOMs are next to impossible now. Yep. That's the problem with Strava. The more you use it, it's
the harder it gets.
It's I've done a segment 100 times over the last 5 years. It's like trying to get better than, it's just a PR is darn near. It's just so hard. For
those that think we're talking in code, Strava is an app that tracks your bike rides. A KOM is when you, on a certain segment of your bike ride that they track, are the fastest ever to ride that segment because they keep track of everybody that rides it. And a PR is a personal record. So that's the fastest you've ever ridden it. So fun. I love Strava. It's both Chris and Maya's favorite mobile app, I think.
It's used frequently, for sure.
And as for me, I'm going to go be a tourist in my own hometown. My folks are going to watch our kids, and my wife and I are going to go stay in a hotel in our own hometown of Colorado Springs, which should be kind of interesting. I've never done that before. Play tourist.
Colorado Springs.
Yep.
Interesting. What's special about Colorado Springs?
Well, it's got Pikes Peak there, which is pretty cool because the town itself is at about 6,000 feet, and the top of Pikes Peak is 10 miles away as the crow flies, and it's over 14,000 feet. So it's a pretty impressive mountain. And then I like the west side, so the side that's in the mountains. There's a little town called Manitou Springs, and it has its own. It has this penny arcade that's really big, and it's been there since I was a kid, and it hasn't changed. So I'll go play the penny arcade games, and there's saltwater taffy store and ice cream shops and kind of fun restaurants and a little creek that flows through it. So that's probably what we'll spend our time doing.
Cool. Yeah. When you say, staying there in the area, and you mentioned Colorado Springs, the first thing that came to mind for me was Aspen, Vail, that kind of, but it's probably crazy, ridiculous, expensive right now too.
Yeah, no, Colorado Springs is a little bit more affordable than those places. Since it's on the Front Range and it doesn't have the sort of hoity-toity reputation as Aspen or Vail or Telluride, it's definitely more affordable. And the thing that it's really famous for is military bases and right-wing politics. So that's kind of what it draws more than anything. So there you go.
There you go. It's a mix for everyone there.
Yep. But so that'll be fun. Here we go. We're going to talk about encryption some more. We thought we were going to do 3 episodes on encryption, and guess what? I think we're going to do 4. It's just there's that much to it, and these episodes kind of live forever. A lot of people like to go back and learn some stuff from past episodes, and there's just more to talk about with encryption. It's such an important part of being a software developer. And knowing what you're doing when you use these encryption libraries and what they're doing, and just kind of how to apply them to your use cases is so critical. So today if you thought last week was getting hardcore by understanding how TLS works, this week we're going to get even more hardcore because TLS is sort of for free and it's kind of a commodity, right? If you're writing a website, you're using highly available libraries to just use TLS. You don't have to do much, and you just get it. You just press a button in AWS, or you just put a little line of YAML into your CFN declaration, and out comes TLS. Now we're going to talk about stuff where it's more on the bleeding edge of how people are using encryption, but it's so important. It's about encryption in non-website types of communication. So person-to-person communication, group communication. And this stuff is still very much in flux. Everybody knows that iMessage is encrypted end-to-end. Everybody knows that WhatsApp is encrypted end-to-end. So we're going to talk about kind of the underlying things that are at play when you do end-to-end encryption and kind of where that is in the software space right now. Chris, you'll take my sort of general introduction and get more specific with it. Go ahead.
Yeah, so we're talking about end-to-end encryption, and specifically this is where two parties are communicating and they're going through an intermediary, but the intermediary just cannot see what the messages are, right? It's only encrypted traffic going through it. So kind of that guarantee that no one else can see this, no other company, no servers can actually decrypt these messages, see it in plain text. It's a secure end-to-end communication channel between two parties, but going through an intermediary, right?
I want to just point out that this has two purposes too. There's the obvious purpose of like, I don't want people reading my messages no matter what. Like, I just want them to stay, I have a conversation with you, Chris, or you, Rich. That's between us. That's not for anybody else. That's not for Facebook. That's not for Google to read. That's not for Apple to read. So that's the one part of it. And then there's the other part of it too, which is that those companies, by limiting their access to the messages that we have with each other, they also limit their liability. They don't have to be responsible for making sure that people are kind of not breaking the law because they can't. So it's really two sides of this. Everybody gets protected when things are encrypted end to end.
Absolutely. I think that was definitely one of the big appeal for WhatsApp when they came out of the gate kind of doing this from the get-go. It just did not want to have any of that liability that goes with what are people saying, using our software, and is a illegal activity going on,
NSA comes along and says, hand over the keys, and they say, I'm sorry, we don't have
them. Yeah, exactly. So yeah, so let's kind of go through some examples of just how this works, and specifically we can start with there's a company called Virgil, and they have an SDK for doing this end-to-end encryption. So this is for people developing apps that want to have this kind of secure messaging while going through a server. It's a client. It's a client-side SDK that you can implement and allow you to do this kind of messaging. So let's talk about how does this work? And so it is based upon public key encryption. So there are public and private keys for all of the users that want to use this system. The public key needs to be published somewhere. So like we talked about this in the previous episode with like digital SSL, digital certificates, SSL certificates for servers, where you have the certificate authority is the one that is where you're publishing the certificates to, and the certificate has the public key associated with it. So for Virgil, they have some infrastructure that you can use for publishing the public keys of all the end users that are using your apps, that are using this SDK that need to communicate securely. And then the private keys, those are kept only by the end user themselves, right? And just like we talked about with TLS, like that, and just public key encryption in general, like the only one that can decrypt the message is the one with the private key. So it's very sensitive. You need to keep that secret. So that will be kept on the end user's device. Now they do have a bit of a problem, right? Because with something like this, an end user can log in multiple different ways and use your app potentially multiple different ways, right? They could have a tablet, they could be using like an iPad and also an iPhone.
Web browser.
Web browser, right? Yeah. So you can't so what do you do there? So what they do is part of their infrastructure, they do allow for the storing of the private key in their cloud as well. So this way, when you have a new device that you're using that doesn't have the private key already embedded in it, it can then go communicate to the cloud and say, hey, I need the private key. So now you have to how do we secure that? So pretty straightforward.
I'm guessing it works very similarly to how TLS works in the first place. Like, okay, well, you use public key encryption in order to establish authenticate yourself, and then once you have the public key encryption working, you can pass over that private key.
It doesn't need to be that complex, because at the end of the day, like, the private key is essentially it's a password, right? So for this particular case, you just the user, they have a password and they use that to encrypt the key, essentially. And so it's basically symmetric key encryption, right? But only the end user, their password is the encryption key. So only they know it.
Okay.
Right. So pretty straightforward, pretty very much in line with kind of like what we've been talking about. But
that makes sense. I just want to add more color to that, because your password essentially is your private key. Kind of means that you can't lose it. Like, unless you lose your password, you're probably going to be able to have your private key. Like, that's just the way that you get it. I'm just thinking about this like from a more holistic approach of like using different devices, or you can do forgot your password. Maybe you can recover your key that way, like by creating a new password, therefore kind of getting back to your key through some other roundabout way of getting back to that key. But basically the idea is, if your password is your key, then it's something that's in your head or something that's in your password manager, and that way nobody else has it. Mm-hmm. Cool.
Yeah. And they do. It gets into some nuances, like what happens if you do forget your password, and do you have to basically create a new public key, private key pair type thing. So, but those are kind of like exercises left to the reader, if you will.
Sure.
Yeah. So there's public key, private key. So when the user wants to send a message, it's going to go look up that particular recipient in this server infrastructure, right? Say, okay, I'm going to go send a message to, Sally. Go look up Sally in the server and get her public key, and then it's going to go ahead and use this public key. And we would talk about public key encryption, so it's going to use that public key to encrypt the message, and then it can now send the message to Sally. And then when Sally receives it, of course, she's now going to use her private key to now decrypt that message, right? Mm-hmm. So the encryption and the decryption all happens client side. None of this is happening server side. And of course, it's only encrypted data going through the server now, right? So not readable by anyone on the server side. It's only readable by me and by Sally.
So it's really happening client side. So like you said that the key was stored on the server, but the client is going ahead and grabbing that key and downloading it, and then okay.
Yep, absolutely. So all that encryption, decryption definitely happening client side.
Okay.
And part of this as well is just we talked about this past with TLS. Same thing happens here. So the message is also going to be signed to verify that it hasn't been tampered with, and it's coming from who it should be coming from, right? So the authentication part of it. So, and this is kind of much more typical, at least the way that Virgil describes it, is much more typical to the traditional code signing that you talked about in the previous episode, right? So the message is going to be signed by the sender's private key. So like me, when I've created this message, I use Sally's public key to encrypt it. After I've done that, I've now encrypted the message essentially with my private key. And now when Sally receives it, she will look up my public key and use that to decrypt the message. And then she can use her private key to decrypt the inner envelope, the actual true message itself.
Mm-hmm. Yeah, the thing she's decrypting is like that signed message digest. Yeah.
Yes.
Hey, this is Rich. Please pardon this quick interruption. We recently passed an internal milestone of 50,000 listens, and I wanted to take a moment to thank you for the support. I was also hoping to encourage you to head over to iTunes and leave us a review and/or a rating. Positive feedback and constructive criticism are both incredibly important to us. So give us an idea of how we're doing, and we'll promise to keep publishing new episodes every week. Okay, let's dive back in.
So that's kind of how it basically works for one-to-one, right? So pretty straightforward, really pretty similar to how TLS works, except now we're using just we have to figure out how to do public key, private key on both sides, right? So that's why there's some intermediate service in the cloud service that's a repository for having this user directory, if you will, with their public keys that are available for people to go look at. So it's kind of like a certificate authority, if you will, but for this end-to-end encryption. So how do we deal when there's multiple recipients? So if I want to send a message not to Sally, but to Sally, John, and Rich all at the same time, any ideas how we might do this?
The most obvious thing is if we're using asymmetric encryption, we would go get Sally's and John's and Rich's public key and encrypt our message with those public keys and send them over. And then they would use their private key to decrypt. It's all the same message. So they would each, the message, like encrypted message, would look different to each of them. But once they decrypt it with their private key, it should look the same.
Mm-hmm. Yeah, so I mean, we could do something like we could duplicate the message, right? We could say whatever the message is, like hello world, and we have we know that I'm going to send it to these 3 recipients, go look them up, get their public keys, take hello world, encrypt it with Sally's public key, then get your John's public key, encrypt it with that key, and then the same thing with Rich's public key. And so now we've duplicated the message there's a copy for every single recipient, encode a message, and then now they can all, once they receive that blob, they can go ahead and decrypt.
That might get a little hard if you were going to try to send a message to 1,000 people. You might start to weigh your phone down a little bit.
Yeah, or the networks and your broadband, your data allotment as well. So not just that, but also just the size of the messages, right? Like if it's a larger message, there's issues with duplicating it. So not very efficient. Like it would get the job done, but it's not very efficient. So what we can do, I mean, there are techniques for doing this a bit more efficiently, and this really kind of builds again on like what we've talked about with TLS. So really, it boils down to using both symmetric encryption and public key encryption here. And this is where we can get the win, right? So we can encrypt the message once with a symmetric key, and then we can use the public key encryption to share that symmetric key with all parties. So the duplicated part of it is really just the encoding of the symmetric key once per recipient. But that's small, right? Because it's just the key.
Is it going to be just like TLS where we go ahead and make up a new symmetric key for every group conversation that we do? Like, okay, Sally, John, Rich, going to have a conversation with them. I need to go use their public keys to send them a symmetric key. Let me make one. Now let me encrypt it with each of their keys and send it on over. And they can decrypt it. Now they have this symmetric key.
Yeah, exactly. So, I mean, so it literally is like the steps are, first you're going to generate a random symmetric key. Right. And then after that, you're going to encrypt it with that symmetric key. And that now creates your ciphertext. And then what you're going to do is you're going to take that symmetric key and you're going to encrypt it with the public key for every one of the recipients. Right. So you're going to have N encrypted versions of that symmetric key. And then what you'll do is you'll actually create a secure hash of that symmetric key. We'll talk about why that's useful. And then once you have all that bits, so now the information that we have is we have the encrypted message with the ciphertext. We have an encrypted symmetric key, one per recipient. We have a secure hash of that symmetric key, the encrypted symmetric key. And then, so now we just stitch all that together, right? So the message that gets sent out is that ciphertext. It's the secure hash of the symmetric key. And then it's the encrypted symmetric key for each one of the recipients. So that gets sent to everyone.
Okay.
And then now when the recipient gets this message, what they're going to do is they're going to try to decrypt each one of those encrypted symmetric keys, right? And so the trick is like, how do they know when they've decrypted it correctly?
It can't be like this one's this one's John's and this one's Rich's.
I mean, you could do something like that, right? I mean, you could just put some metadata in there or whatever and say like, okay, here's the key for, you could say like, oh, here's my unique ID or something like that came from the server and I'm going to associate with that. But you don't need to, right? Because what you can do. And it feels like
doing that might create a little opening, like a little bit of there's some data about the recipient that is knowable to other parties.
Yeah, well, now it's possible that the recipients know something about identities, right? Who else is on that conversation, right? Exactly. Which may not be good.
So this thing that you're about to say kind of helps with that, I think.
Right. So
you try to decrypt all of them and then compare it to the hash, right? Like then hash it and then compare it to the hash.
Right, because we generated the hash, right, of the symmetric key, right? And that's that one-way function that creates this hashed value of it. So if we take what we think it is and we apply the hash function to it and get the same value, then we know that we have the right key, right? So that's what they do, right? That's what you do. So you take your private key, you decrypt each one of those encrypted symmetric keys one at a time. Once you've decrypted it, you then run it through the hash function, right? To see if you get the same hash value. And if you get the same hash value, now you know that is your key. And now you can use that key to decrypt the message.
Cool.
Yeah.
That's pretty cool.
Yeah. So it's nice. It's tight. It's efficient. You're not sharing anything about identity. There's no way to know like who else is on that other than like you just have these encrypted keys.
They could even obfuscate like how many people are in the thing if they wanted to. Like, here's a couple extra just for fun.
Sure. Yeah. You can do extra. You can't do less, right?
Yeah, no.
That wouldn't be nice. But yeah. So that's essentially the technique, right? For doing this one-to-many encryption. Like we don't need to make multiple copies of the message. We can encrypt the message once, but we're going to use symmetric encryption to our advantage here. So that we just do the encryption once, and then we can use the public key, private key to make sure that only the parties that should be able to read it can do it. And by the way, this is called envelope encryption, and this is just a really common technique in encryption in practice. And it's really important for just scaling encryption to be able to go really fast. So we talked about this previously, how symmetric encryption is so much faster than public key encryption. Dealing with the math, you're dealing with like bit operations like XOR instead of dealing with prime numbers like you are with public key encryption. And so when you want to be fast and but you don't want to share a secret, you're going to use this combination of public key encryption to share the secret and then use the shared secret to do symmetric encryption.
Right.
Yeah.
So there's another thing that we're going to talk about in today's episode. And as sort of an intro to it, I just want to talk about an experience that we had with one of our clients. So we were building some direct messaging, and I brought this up before, we're building some direct messaging for Zupix. And just because of my awareness of how WhatsApp works and how iMessage works, it's like, oh yeah, this should be end to end. Like, let's just do that. That should be easy and straightforward because other companies are doing it. Let's do it. And that was not my experience in the market. For one, I didn't feel like it made sense for our team to build the entire messaging infrastructure and interfaces. Like, this is a solved problem. Direct messaging really isn't the core of what Zupix, the company, is about. So why build it from scratch? Well, it's like a buy versus build decision. This one felt like a buy. So we started to look at all the options out there, and I'll name some companies. Twilio, we looked at another one called PubNub. We looked at Comet Chat, and we looked at Sendbird, and all four, and some others that didn't even make the cut. Those were the kind of final four. All four of them, when I said, yeah, we're really interested in your end-to-end encryption capabilities, we're definitely going to take advantage of that. They all said, oh, yeah, so we definitely support that. You should totally check out Virgil security. And I was like, oh, so you don't really, like, you have to use this other thing. And the like effort to implement Virgil security on top of one of those existing third parties is non-trivial. I mean, it's definitely some code. Maybe you can do it in a couple months, but not a weekend project, because you have to think about all the things, right? Like we kind of mentioned one earlier. We talked about what happens if you lose your key. Well, Virgil has some ways of handling that, but you have to create UI for it. Virgil doesn't have any UI for that. Or what happens if you have a 2-person conversation that turns into a 3-person conversation? You have to make a product decision around that. So there's just corner cases and things you have to think about in order to create proper end-to-end encryption direct messaging platform. And it is not something that you can buy today. And I won't name the company, but one of those four, I got all the way into the conversation of how to do this with their product. And they said, if you do this, you'll be the first company that's ever done it that uses us. And I was like, wow, that is fascinating. And they also, and so now's the segue into the last part of the episode. They also said, by the way, you should check out this other protocol if you're going to do this, because this, some companies that are looking into this are kind of landing on this protocol. So maybe you can talk about what that protocol is.
Right. Yeah. So, I mean, we talked about how like this is kind of secure end-to-end encryption is becoming more and more prevalent and necessary. TLS is well established, 20, 30, I mean, however many years it's been out there, when most of the communication was just point to point, right? It's between a client and a server. now we're so used to things like chat and instant messaging and group messaging and applications like Slack, video calls, conference calls. I mean, just so much in the way of just this multiple parties and want to have secure messaging. So there's a lot of work out there. There's a lot of folks they've built apps to do this. And then there are groups that are getting together to kind of put together standards and specs for doing this. And so one of those is Signal. So Signal is an open source effort to kind of spec out a protocol for what does it look like for having secure messaging end-to-end for end-to-end encryption. And it deals with it. I think it all came out from the efforts of building an app to actually do this messaging between two users that was end-to-end encrypted, so that the server didn't know about it. And so Signal, I think it was created in 2013 by OpenWhisper. It's kind of a codification of some of the techniques we just talked about, right? It's instead of leaving it to everyone just to roll their own, it's they're trying to actually spec it out and say, okay, here is the actual protocol. And not only dealing with just the encryption, but also dealing with things like, formalize, like how do you do authentication, message integrity, destination validation? How do you repudiate messages and participants? How do you deal with
you got to stop you there. What does that mean? Repudiate?
I believe this is to basically say hey, this participant shouldn't be part of this anymore, right? Okay. Or this message shouldn't be part of it. So to remove it, it deals with order of messages. So dealing with message delivery, it deals with offline and asynchronous delivery of messages. So just kind of
that's just a ridiculous number of things, right? Like you just listed off some things that if you were to go into a client meeting and they were like, yeah, we want to build a chat app, you probably wouldn't get into should we verify the order of the messages is absolutely trustworthy? Mm-hmm. That's hardcore. Yeah. Like when you care about that stuff, you're really building a serious application.
Right. Yeah. Well, like I said, your example of attack at dawn, right? You don't want at attack dawn to be what shows up in your client, right? So so things like that become important in practice. They've also done with the Signal protocol, they've done some interesting things with just making it more secure in case the secret is compromised. And so they have this they call it it's a double ratchet algorithm, which is essentially it's an algorithm that is constantly renewing and maintaining those short-lived symmetric encryption keys. And so what happens is it means that if someone can actually get one of these short-lived keys, if they actually do get it, they can only read the messages that are still using that key, but it's constantly changing. So it kind of forces, in order for someone to truly be able to see what's being messaged, they have to be able to intercept every single one of the messages. They can't just do a few packets here and there. It has to be everything, right? So it's kind of a key part to just it's taking up the security a notch by having this negotiation, this ongoing renewal of those short-lived session keys. Mm-hmm. And it's definitely gained a lot of traction. So it was originally developed by the folks that built the Text Secure app. It was then incorporated. WhatsApp, the instant messenger app, uses it. Skype uses it for private conversations. Facebook Messenger is using it for its secret conversations. So a lot of traction out there for folks to implement. They do have, like I said, it's open source. There's SDKs out there for things like JavaScript and Java and C. So really easy to get going and using it. So definitely something to look at.
Yeah, for sure. And I would say, it's all of this is not commodity stuff, right? It's open source and you can play with it, but you've got a lot of work to do to turn that open source stuff into a real application. But, I'm going to make a little forecast. I would say within 2 years, maybe 3, that this will be kind of commodity. This will be practically built into the work you do, right? Oh yeah, I need to add end-to-end secure communication between my users. Oh yeah, just npm install, boom, you got it. Now you've got it.
Yeah, absolutely. And I think just encryption in general is going to become more and more important. It's one of the reasons for doing this series is just that we see, I mean, there's data breaches all the time. There's hacks all the time. Like, who can you trust, right? So I think it's the responsibility is going to be pushed back to us, the end users, to really care about encryption. And we should be looking to make sure that like our data is encrypted and it is stored encrypted by the server so that when they do get hacked, like they're not seeing anything, they're not getting anything. So privacy, encryption, really, really important. And it's going to become much more so because the hacks are not stopping. They're getting bigger. I mean, just recently here, it was, what was it? Citibank, I believe it was, or was just hacked.
Capital One.
I'm sorry, Capital One. Yeah, Capital One by an engineer here in Seattle, and someone just misconfigured a firewall on a web server, and that was enough for the person to gain access. And it's like millions and millions of people's confidential financial information just boom out there.
Right. You said that it's up to us, and I do think that there's users pushing for this and people that are responsible and making sure that they use secure services, but I think one of the biggest market drivers is that there's more and more liability on companies, right? As each new breach happens, and as different governments around the world make new laws, they're starting to put a lot of onus on companies to not let this happen. And so as software developers that typically work for companies, not for ourselves, we are put in the position of like, okay, what can we do for a company to make sure that the company doesn't share any liability if something happens, like if a terrorist attack happens or something, like what are companies doing to make sure that they are not on the hook financially for any damage that gets done? And that's where this encryption comes in. It's like, okay, keep us out of it. Companies are like, what can we do? Like, to not even be able to see this information or have access to it. And so that I think is driving this almost more than anything.
Yeah. So, I mean, you're right. It cuts both ways. It's like for like these kinds of breaches, it's the end user side aspect and like, hey, I don't want my information compromised, but it's also, it costs these companies millions and millions and millions of dollars. And it's kind of incalculable how much damage it causes when it does happen. So, they would definitely like for that to not happen as well. So who knows, we might see more and more services that pop up that are basically the equivalent of a HSM in the cloud. And that's used as an intermediary. And so HSM hardware security module, we'll actually get into this in the next session.
Okay.
And that is kind of a black box where the keys are stored and the key itself never leaves that black box. So whenever you need to use that key to decrypt something, that decryption happens inside that black box. And the only thing that comes out is the decrypted data, never the key.
Oh, interesting. Well, I'm looking forward to that conversation next week.
Yeah. You bet.
Enjoy your weekend, both of you. Thanks, Rich. Thanks, Chris.
Thanks, guys. All right. We'll see you next week.
Thank you.
All right. Bye-bye.
Well, dear listener, you made it to the end. We appreciate your time and invite you to continue the conversation with us online. This episode, along with show notes and other valuable resources, is available at mobycast.fm/75. If you have any questions or additional insights, we encourage you to leave us a comment there. Thank you, and we'll see you again next week.